So today's lesson, we're talking about the lamps. Lamps are the incandescent lamp. So this is for the when the electrical current flow. So in this case, I square R. I is a current, I is a resistance. So I square power loss cause a heat and then a light coming out. Here we LED is an extra low voltage lamp. This is a voltage less than 550 volt. Discharge LED is a when the current flow, so it can have this interaction with the gas and the light will be coming out. Usually a lot of the power losses in the light, incandescent lamps are now less than utilized. Now we are using the discharge lamps. Discharge lamps are the most economical. Discharge lamps are also provide the most illumination. So illumination level on the particular surface must be measured with the light meter. It must have the appropriate recommended value. So this is for we're talking about the introduction to the lighting system. So to achieve the such recommended value, the appropriate number of the light and light power must be arranged. So the ELV lens are the tungsten with the own reflector, so that the light at the temperature of 3000 Kelvin, so light will emit. Gaseous lens are also the discharge light. They are provided by the gas on the vapor discharge tubes. So that in this case, the cable side and the light level we also need to get the table as well. So cable size is small, rather cable in a short distance. Basic operation principle of the discharge lamp. When the voltage is applied to the static electrode, the positive ion flow from the static electrode to the main electrode. Those are interact with the gas molecule and the light is emitted. This is how the light is produced. So this is for the lighting circuits diagram. Here, this is choke, this is capacitor, this mercury vapor light. So the electrical supply system for the mercury vapor light is this diagram. Light is an electromagnetic wave. When the electromagnetic waves are moving, so that in this case, the I square R radiate the energy release are provided. So this is the wavelength and the energy level. We can draw the graph like this. So light of the lamp. So the light of the lamp is depending on the current flow and duration of the usage and the number of switching time and the voltage level. So those are the light of the lamp. That is depending on the two aspect. So the use of the discharge lamps are we use a discharge lamp in the outdoor, radio, roadway lighting, flower lighting, and the security lighting. So in this case, our industry we also use as a high base and tight luminaires are utilized in the industry as well. So those are the tutorial questions. You answer those tutorial questions. So this is the answer for the tutorial question. The next one. So this is a lighting control system. Lighting control system here you see there's a manual control, automatic with this meter switch, master switch. So this is the manual control circuit diagram. This is automatic. The automatic control with the master switch. Automatic control with the master controller is on off connection. This is when you are this one on, the weekends are manually control. This one off, you can use as an automatic control. So timer switch are provided for the energy level reduction. So this is the timer switch. So this is timer switch provided for the energy efficiency reduction. Tidal switch, they also the digital electronic tie switch is also included. So this is the timer switch connection. Here will be there's a tidal switch connection here like this. Tidal switch. Tidal switch are connected to the switch. So this is the tidal switch. And ordinary on off switch is this is tidal switch. This is the ordinary on off switch. On off switch. So this diagram. This is the manual switch, light sensitive switch, and the manual switch. Manual switch and a performance and a light sensitive switch. This is a cannot sense the real light situation on the outside. So light sensitive switch to be utilized. So here with the power supply, this is for the tidal switch, is relay look like this. So that this line switch says outside light. When the outside is a light is a low, it is a tidal switch with operate a relay and then low is a connected. So that can be this is a function. Then you go to a cross B function. So in this case, adjustment is have to do that depending on the light level and sensitivity and the time. So light dimmer switch is here. So this is the light dimmer switch is include a variable resistor. Variables are radiant inductor and also solenoid. So the variables are secondary tapping on the transformer and also the magnetic amplifier. So this is the electronic light control system, electronic electric and neutral. So this is the diode, this is gate, and this is triode. So this one will be the will provide us a gate signal, and then will be provide us a control, so light control. And also that you have to do this electronic light control is composed of the diode, triode, and the gate control circuit. By controlling the gate firing signal, the current flow from the T2 to T1 and it can be controlled. And after that, you have to do that. Those are exercises. To do exercise, you have to do it. So the wiring system, we are talking about the wiring system. Wiring system includes general wiring and the fire protection, heating and adding system. Fire protection includes the testing of antennas and the conjunct associated wiring theory elsewhere. So here is a protection system. Wiring system is this is a outside power line. So power line from here we connect the wire to the consumer service wire and connect the main switch. So this is the way wire is connected. So this wire is included the secondary wire. So we run the wire on the secondary wire and we clip it. So this wiring system. So this wiring is provided either by the overhead system or the underground system. Underground system is we use a steel trunking cable, ladder, risers are utilized to bring the electrical cable to the applicables are low. So this is the underground system. And main switch board is also included. Main switch board is this is the main switch board. The main switch board controls the whole system. This is the main switch board controls the whole electrical installation to the building. So this is what the main switch board system. Consumer main coming here, main switch board and connected to the distribution board. So that then wiring between the power line to the main switch board is the consumer main. From the main switch board to distribution board is we call it sub main. So DVR the distribution board is generally fed from the sub main to control and protect the portion of the installation. So this is that we also have to do this tutorial 3. So this is the electrical wiring system. Active wire, the single pole switch and low connected neutral. And this is for the two double pole switch connection. This is single pole switch, double pole switch. So this is a single pole, double pole. Here will be the active neutral R. This is switch and this is light. So this is the wiring, typical wiring circuit diagram. So we have to run the wire like this. And also there will be the connection here. This is connector and simplified circuit diagram. This one we can also connect it. Here is a more than the one switch. Is a circuit more than one switch. This is a switching diagram. So circuit diagram, this switch diagram, and this is the wiring diagram. Wiring diagram we connect it like this. If you use a connector, we can also connect it like this, simplifying the circuit diagram. So the wiring associated equipment we use a 240 GaN switch, mounting block, conjunct junction box, and coupler, elbow T, lamp holder, and also 3-go cable also utilized. So they are we have to do the tutorial question. And here with the connection of this is the elbow T joints. And also here is a to run this one is a screw. And this is a single pole switch, 2-pole switch, GaN switch connection. Here is a electrical wiring, rear electrical wiring diagram. Also, we have to run this OSB on the wiring loop. AS3000 wiring rules, there are two things, AS3000 and also AS3008 for the cable selection. So AS3000 wiring rules, part one is a scope application and fundamental. So we have to read as a cross 4x4, 4x6, 4x7, 4x19, and 4x25. Those things are that we can talk about the active conductor appliance cable, also the circuit. And also you have to read as a 1x4x46 electrical equipment, 1x4x51 enclosure, 1x4x58 installation coupler, 1x4x60 insulation system, 1x4x64 luminous, 1x4x71 plug, and then 1x4x72 points. Those things you have to read. So here is a socket outlet connection diagram. This is a socket outlet connection diagram. Wiring circuit socket outlet, the electrical wire will connect like this. Also, that we also see that our main switch board. Switch board should be installed in the suitable dry, well ventilated, where the access is not obstructed. So this is a switch board connection diagram. So where the switch board should be installed, and also we also have to do those exercises at the conductor enclosure, insulation, plug point, socket outlet as well. So this is the main controls electrical circuit diagram. So this is the area wire, service wire, power point. So the three phase are home in connection like this. So this is the main control circuit. Main control circuit is this is for the supply. This is in this case a supply neutral link, add link, and fuse at the neutral wire, and so add connection. So here connect the kilowatt meter, main switch, and also fuse. And also this is the electrical load. And this is a consumer neutral link. So this is for the main switch circuit wiring diagram. Is you can see that this one. So in this case, our main switch board to load, that will be the wiring system. In this case, our cable link from the main switch board to load can be included in the ceiling space inside the plaster board, line wall, and partition inside the skirting, trunking, and the power duct. So in this case, we have to read as AS3000 cross 3x1x2. The type of the wiring system can be enclosed. This is on the surface partially surrounded by the thermal insulation, fully surrounded by the thermal insulation, and then body direct into the ground. So in the enclosure on the surface, partly surrounded by thermal insulation, fully surrounded by thermal insulation, and supported by the cantilever wire, supported by the insulator. So this is the 3x1 the cable type, application, and the wiring system. You can read this one. Those are the review of the electrical equipment, also the electrical protection, and also the AS3000 application. So those are I am reviewing. So and the enclosure is included on the surface, partly surrounded by the thermal insulation, fully surrounded by thermal insulation, as well as the underground. It's supported by the cantilever wire, and also the supported by the insulator. So those are the kind of the electrical insulation system. So that we have to read that they are 3x1 cable type application and wiring system as well. So then we are talking about the main switch board location, where we should allocate the main switch board. The main switch board shall not be located not more than the one floor above. The switch board wiring system is a switch board wiring shall be designed to withstand any thermal magnetic effect on the conductor. The conductor shall be run at the back of the wiring panel. Sheeted cable shall only be used with the insulated panel. So in this case, we use a 3x3x2x6 is an impact, 3x2x2x7 is a vibration, 3x3x2y is a mechanical stresses. So this is for the main switch board electrical wiring system. We have to protect those things. And also the current carrying capacity. Every conductor shall have the current carrying capacity across them with the AS3008. Operation temperature is at level 3x2 and also the limiting temperature as well. Maximum or minimum cable size is 4 mm square. Conductor size we have to follow the cable level 3.3. So voltage drop we have is determined the cable size. So that we follow the AS3x6.2. In this case, the voltage drop is not more than plus or minus 5% of the nominal supply voltage. set the cable appropriate to the maximum demand of the load. So here will be the tutorial. So we have to do the tutorial question and also typical arrangement of the switchboard. So there will be the circuit breaker, RCDs, residual current devices. So this is main switch kilowatt hour and also main electrical load and other links. We can connect like this. So this is a connection of the arrangement of the advanced neutral link RCDs connection. So this diagram shows the advanced neutral link and the RCD on the main switchboard. So in this case, the conjugate cable can be run at the cavity wall, flow joint, and the ceiling. Cable layout switching diagram to be drawn before the installation. Then you have to do this tutorial. So we are talking about the fire protection and the residential smoke alarm system. So to alarm the occupant of the building in the event of the fire breakout, so this is a smoke detector detect the smoke and sound the alarm. We also utilize the sprinkler system, smoke and heat detection, and automatic water spraying system. So in this case, a direct electrical supply with the smoke detector, which cannot be indirected by the main switch. So service wire here, main switch, this main, and this is a supply to the smoke detector. This is a smoke detector wiring arrangement. Here is a alarm system. When the smoke hits up, so there will be the electronic circuit control, and then the alarm will be sound. So this is electronic circuit control light system. Location of the smoke detector is close to the bedroom, top of the stair, outside the bedroom. In this case, we utilize the ionization smoke detector system. But in the kitchen, we should use the thermal smoke detector. We need to avoid the location of smoke line in the airstream that may carry the smoke particles. Limitation also avoid to install the smoke alarm in the kitchen and so that unless a thermal smoke alarm is utilized. So in this case, we should not use the smoke alarm in the bedroom, garage, and very humid place, fireplace, and also we should use the smoke alarm 3 meters from the bedroom and 75 meters from the gas heater. So while this is like the smoke alarm is controlled by the NE circuit, which are energized at 24 hours per day supply. So we have to avoid the install the smoke alarm at the dead space. So this is a 300 millimeter from the corner is a dead space. We should avoid the smoke alarm. So we should write the smoke alarm like this. This is for the electrical wiring diagram for the smoke alarm system. So in this case, we also have to utilize the appropriate clause of the AS3000. So the AS3000 4 by section 4. So smoke alarm system, you can read the smoke alarm system. AS3000 rule. Then you have to do the those exercises. Then we also talking about the hazardous area. Hazardous area is area in which the explosive atmosphere present or the may be exposed to be present. Special precaution needed for the construction, installation, and use of electrical equipment. So the hazardous area can be the class 5. Class 1 is a flammable liquid gas vapor. Class 2 is a dust. So class 1 is a zone 0 is a explosive gas is a present continuously. Zone 1 explosive gas is likely to be occur, and zone 2 is a explosive gas is not likely to be occur in normal operation. But if it occur, it will exist for the short duration of time. And this is for the hazardous area classification. So there will be the pure oxygen, how the fire happens. How is a mixture of the oxygen, heat, and the fire substance. So we need to protect the fire by exclusion, explosion, energy limitation, dilution, avoidance of the ignition source. We have to utilize the equipment across and with the AS2380 system. So this is so this will be the hazardous area here. Interestingly, say the equipment. This area, then we have to use a fire enclosure. Fire protected enclosure have to utilize. So this is the electrical system for the fireplace. So we need to protect the sea and the fireproof enclosure is important. No open wiring, no sodium vapor light, no battery charger, no switching devices in the hazardous area important. So that we also have to utilize the section 7. Section 7 is separate electrical installation, we have to follow the section 7. In this case, we have to know about the hazardous area, appropriate reduction method, electrical equipment method. AS6079 is a special electrical equipment mentioned for the hazardous area. Then we have to do the tutorial hazardous area. Here will be the explosion protection technique. This is the hazardous explosion protection switch. Here will be the explosion protection switch. They are type and they are symbol. So our explosion protection switch, they are type and they are symbol. And here hazardous areas are electrical wiring, the motor system. There's a motor enclosure for the hazardous area. There's a hazardous area 2 and equipment. Those are we're talking about the hazardous area. Then we're talking about the earthing system. Regarding the earthing system, this is the earthing system. Protection for the earth leakage at the iron body of the equipment is important. So in this case, we need to protect the earth fall on the supply system to installation, on the adjacent building, in the wiring accessory, within the appliance, and the luminaire or the switchboard. So this is what the earthing system, MBN. So earthing, and this is connected to the equipment to the body and circuit breaker. So this is earthing and neutral link connection like this. So in this case, the supply system fault can be when the supply system fault happens, reverse polarity of supply and the open circuit on the supply neutral. In the supply system, overload or the short circuit faults are protected by the circuit breaker or the fuse because of the fault cannot be protected by the circuit breaker or fuse. In this case, a protection of the fault is adding to the metallic bodies or the RCD residual current devices to be installed. So this is the installation of earthing system. So 3-phase system, you can bar, up bar, this is unlike. So this is for the equipment body. In this case, a factor in influencing the magnitude of the output is depending on the low impedance supply, main installation, resistance of output, and resistance of earthing system. Here is an ambient system. A connection between the neutral and the output is an ambient. We use an ERCB and leakage circuit protection. So if the potential of earthing system reach to the 20 to 25 volt, so that they quite operate. So this is the RCD. When the RCD is when there's a normal condition, the current flow from the supply to the load is I1, flow back is I2. I1 and I2 are equal. When the leakage current happens, the I1 and I2 is difference. The difference between the two current produce the voltage. The voltage are trigger coil and the circuit breaker will be off. This is the operation principle of the residual current divider. Here is a connection of the ESCB, a leakage circuit breaker. So in this case, you can see the leakage fiber 3-way line here. This is the kilowatt hour. This is supply neutral link, supply consumer neutral link. This is unlinked. So this is ELCB and this is apply. When the output happens, the current voltage across the ELCB occur. So this voltage will trip off the ELCB switch. So that VE is 0 at the normal condition, VE is present at the output condition, VE trip of the ELCB contact. So here we the circuit breaker, circuit diagram of the main switch here, stove, light, power circuit, RCD, also the stove, also the main switch. This is for the power and lighting load. So this is the configuration of the RCD main switch, also the supply to the hot water, stove, and water heater, main switch, supply neutral switch, earthing, also light in the power circuit. Those are the configuration of those circuits. So SNA supply neutral link, CNA the consumer neutral link, ESCB and last leakage circuit breaker. After that, you have to do that. Those are tutorial question answer. Question. Here is a typical case of electrical wiring system. So this is the consumer neutral link, supply neutral link, earthing, and this is the supply. This is for the switchboard, and this is lighting and the power switch. Typical connection. This is a connection of the main switch. So this is a connection or arrangement of the supply, main model of the main supply. So this is the earthing arrangement is a main switch here. This is earthing wire also the main neutral link, consumer neutral link, also equipment connection like this. So this will be the electrode ground should be the body under the 1/2 meter. So multi-bay arc connection, the earthing and the bedding, electric connection. Also we utilize it. This is what the leakage as resistance measurement method connection diagram. So we have to utilize the electrode, but we cannot do this joint. We can't do the joint in the earthing wire. So at wire side is a current carrying capacity. In this case, we have to apply the table 5/1 of the AR3000. So this depending on the current carrying capacity on neutral wire and R wire, we have to select the R wire side. At conductor side, we have to follow the table 5/2 of the AR3000. So R wire can be the green and yellow, green or the green yellow combination. So this electrode. This is the then you have to do the tutorial. You have to answer the find the cross for the AR3000, ESCP, ambient base rate, consumer neutral link, supply neutral link, adding leakage voltage, electrode, leakage circuit, resistance of the electrical electrode, side of the electrode, side of the electrode. So those things you have to supply in the AR3000. So this is for the electrical trade one. We're talking about the reparation of the electrical equipment, protection, and electrical installation. Okay, the next one is we have to do the electrical trace G103. So the website is you have to enter the IUN college.com/electrical trade 2022.html. Then this is what this side. After you on this side that you can see the IUN college.com/electrical trade 2022.html. So that on the main switchboard you see the E101, 102, 104, 105, 107, 137, G006, G33, G063, and G102, G103. Those are the 30811. For the 30820, there will be mapping table. So this is the mapping table for among the 30811 and the 30820. So that all the things are electrical trade. Yeah, this is all the diploma, advanced diploma, and the electrical trade course. So electrical trade code is you can see the UE11 and UE20 codes are mapping. So the G0103 can be mapped to the UEEL0012. So this is the mapping unit. G012 and 103 and G104. This is mapping to the UEEL0012. Therefore, for the UE30820, by studying the G103 and G104, you can get this unit, UEEL0012. So this is the way how to do the mapping. So that in this case, my lesson based on the 30811, then use a mapping data and then we can transfer to the UEEL00. So UE 30820 codes. So that you see that this UE G103, that will be the workbook. So this workbook include the question. So installation of wiring systems or those questions. So those wiring system questions you can see on the question here, lesson and the question. Wiring system question. And here is the answer. Read the answer. This is the answer for those questions. So that you have to read through the G103 workbook question, and also you need to study the answer. So those are the answer for the all questions. So all answers are provided here. So what you have to do is you read the workbook question, and also you read the answer or question and answer. Then here is a video. So these videos are the cable method protection scope. Those video you have to read the video. Protection against from the otherwise you view the video. Positive cable location, view the video. Building code affecting installation of cable and building, you have to read the view the video. Issue affecting the electrical installation, you have to view the video. Use the installation standard, also view the video. Relocate installation and their supply, view the video. Additional requirement for the caravan park, view the video. Additional requirement for the marina and the pleasure club, view the video. Additional requirement for the show and carnival, view the video. Hazardous area, view the video. The requirement for the installation of cable, SOC and gas saturation ERV installation, you need to view the video. And also the visitor zone around the bar, shower, fish water, you need to view the video. Voltage range, the fire and low, extra low voltage, view the video. Area cable, view the video. And also the underground cabling, you need to view the video. And also technically for the maintenance cable wiring system, you need to view the video. Video, and also this is for the G103. So the G103, I guess I repeat again. Firstly, you have to go to this I2I Technical College Dr. Select Electrical Trade 2022.htm. And from this one, there will be the mapping. UE1120 mapping. So this is the mapping between the old and the new unit. So old code is at 30811, new code is at UE is at 30820. So this is the O and the new unit. So this is the table is you show the O and the new unit. So this is the UE11, so UE20. So the G103 is for the O code is a G103. G103 by G104 is equivalent to UEEF0012. Install low voltage wiring, apply switch GI associated. So this is for the O code speedway. Read this one, you go read this one. So this two combination of the unit is equivalent to this one. So this is for the mapping diagram. Then you have to read this G00 G103. So click the UE and G103. Then you see the workbook. So this is workbooks here. And those are the answer for the workbook. So you read the workbook question and you have to do the answer. After that, those are the video for the all the competency that unit, you can do the video. So this is the way you can study the G103 for the electrical trade 2. So this is a sort of problem in low voltage AC circuit. We talking about the CRO, category oscilloscope. As in all of this session, students should be able to already adjust the control of the basic CRO, check the calibration of basic CRO, measure DC and AC voltage on basic CRO, use the CRO to determine the phase difference between the two sideways. So this is the connection of the diagram of the category oscilloscope. So you see that this way the category oscilloscope. This is a switch die, and this is for the channel A, channel B, so channel A, channel B switch. And this is inside of this cathode oscilloscope. So this is cathode. This is the accelerating electrode and electron beam. The focus electrode is include deflection coil. And this is a phosphorus skin. So this is where all the electrical voltage across this direction coil, deflection coil. It will adjust the electron beam, and the electron beam hit the phosphorus skin and light will be coming out. So there is coming out from the phosphorus skin. So this is the inside connection. Control oscilloscope, switch generator control system. It provides a horizontal switch, time-based control, millisecond activation. So this is the switch dies connection. Here is a triggering circuit. Synchronizing not this is for the switch triggering circuit. So this is the switch generator control, vertical amplifier control. So vertical amplifier control is we can adjust the volt activation. Vertical displacement control. This is the connected to the external input. So this is the connected to ground connection. So this is the volt activation for the external control. Volt activation, and this is the AC ground DC. This is for the also we can connect it to the channel 1, channel 2 dual mode. So this is for the in this case vertical scale 10 volt activation, horizontally 2 millivolt activation, trace center at a 0 point object. So this is the connection like this. And signal DC, change the voltage scale 24 watt deviation and leave the time wave at 2 milliwatt second deviation. That will be the answer like it happen like this. And this is the vertical scale 1 watt deviation, horizontal scale 0.1 millisecond watt deviation. So we have to find the P2P value voltage. So this is P2P. And so this is P2P is a 4 multiplied by 1 4 volt. Voltage by P is at 2 by 4 by 2 is 2 volt. So this is time. Time is a 6 multiplied by 0.1 is 0.6 millisecond. Frequency 1 by T equal to 1 by 0.6 so 1 by 6 hertz you got. And also the body gets K channel A 1 volt deviation, channel B 0.5 volt deviation. Horizontal square is a 0.1 millisecond watt deviation. In this case, voltage P is a this is the voltage P calculation, and this is the voltage P to P is a 1.05 volt. Time is a 0.6 multiplied by 0.6 millisecond. Frequencies are 1 by T, so the 1 by 0.6 is 1666 hertz. So this is E is at 5D, so this is the theta T can be calculated. So this is theta T at 360.1 by 0.6 so 60 degree. Then you have to do this practical exercise. So we are talking about the voltage, vector, and phasor. So at the end of this session, students should be able to define the vector, define the phasor, draw the phasor representation of the AC sinusoidal waveform, identify the leading and lagging phase angle, draw and read the phasor diagram. So what is a vector? The quantity dash has a magnitude and direction. This is the phasor. Example, display of velocity acceleration force. A person travels due to the east for 9 kilometers. So this is the phasor diagram like this. A person travels east for 9 kilometers when travel 30 degrees and not on the east for 37 meters. So this is 30 degree measure, and this is the 7 kilometer. And then the starting point, find the ending point you join. So that person distance, this way you can find it. So that will be 5 kilometer. So this is angle 30 degree. What is a phasor? The phasor representation of electrical quantity. This is the sinusoidal quantity. This will be the waveform here. This is a waveform. So this is a wave angle and a waveform direction and time moving. This is what the waveform will be going like this. Vector and waveform relationship. If we have a more than one quantity, we add 2 there. So this 2 vector is represented like this. Conversion. The reference phasor also is always at 0 degree. The voltage phasor are shown by the open arrowhead. Current phasor are shown by the closed arrowhead. Phasor rotate in anti-clockwise direction. Phasor rotate. Phasor angle are specified either leading or lagging. The top one is leading, this one is lagging. Phasor magnitude are generally specified RMS value. Phasor addition. Firstly, we have to a parallelogram. Then we like this. And then you have to measure the 40 degree. Then you draw this line. And then you construct the parallelogram. And then this one final one. Diagonal is this is for the magnitude. This is a parallelogram method. Then you have to measure the angle and measure the magnitude. So 16 degree. Also the measure with the compass. Measure the compass and then you measure the value. This is 16 volt. So you have to see the example. I enter 4 ampere minus 30 degree. I 3 ampere 0 degree. So that will be the 3 ampere 0 degree this line. And 4 ampere minus 30 here. Then you draw the parallelogram. So this will be the diagonal is it. This is for the resultant magnitude. So this is 6.75 ampere minus 70 degree. This is for the supply 50 hertz volt. This is electric resistor and a coil. We do it 200 report angle 0. So this is the V1 124 angles are 80. So we add the V1 and V2. Then we draw the parallelogram and we measure the diagonal. So that will be the magnitude value. So 250 volt angle minus 28 degree. So 10 angle 45 degree. And then I2 is a 50 angle 20 degree. Then we draw the parallelogram and measure the total diagonal. So that will be the total magnitude 24/5 angle 30 degree. V1 is 10 angle minus 30, V2 is 10 angle 30 angle minus 60, V3 is 20 angle 30. You add. So this is reference current I. So V1, V1, V2. So this is the V1, V2, V3. We measure the magnitude and then find the diagonal. That will be the total magnitude. So this is 27.11 degree. So this is the I1 12 angle minus 30, I2 24 angle 12, I3 24 angle minus 40. Reference voltage ID I1 plus I2 plus I3, you add like this. Then total magnitude, this one. So then when we measure this magnitude, then will be there 54.45 angle minus 18.27. This is reference 200 angle minus 30. 200 angle minus 30. 250 angle minus 50. Then you go and then you draw the V2 VD minus V1. So this is reverse minus 200. So V1 is a reverse. So this is reverse at this one. And this one you construct the diagram. And this will be the resultant value. V2 is 77 angle minus 27 degree. Then you have to do the exercise. So this is for the advanced diploma Bachelor of Applied Engineering. Then you also have to do the advanced diploma. Bachelor of Applied Engineering, electrical electronic courses. Then we are do the electrical diploma 2022. So you clear the electrical diploma 2022, IQIT College of electrical diploma 2022 of HPM. Then go through the video lesson. YouTube video lesson for electrical engineering lesson. So you click this one. So that you can also enter IQIT College of electrical diploma 2022 study option 3.htm. Read the lesson. Yesterday's last week we talking about I have talked about how to read the electrical computing. So G069. So this is the project manager I talk about. This week what you have to do is go down here G1 or 2, go down. G1 or 7, go down. You have to read the electrical fundamental, G012. Electrical fundamental. So the link here, highlight computer.com/video lesson.htm. So click this one and read the page 190 to 195. And then you also read those video. Do the video and the written notes for the video are that you can download from this one, page 190 to 195. the video lesson.pdf, page 190 to 195. So this is video lesson notes. You can see page 190 to 195. So page 190 to 195. So those are the written notes for the video lesson. Those video lesson, you can read as a written notes. So this is a video. View the video and read those written notes. This is for the advanced diploma electrical engineering.